Hello friends, this is Sanchit Mehra, and today in this video I will be explaining you about the use of shared pointers in C++, as to why shared pointer is necessary for the memory management in C++. And firstly, we all know that necessity is the mother of invention. So why shared pointers was incorporated in newer versions of C++. So let's study what was the problem there in the previous versions of C++ regarding the memory management and how shared pointers now overcomes it. So now let's consider it a class that I just made as class foo, in which constructor is there and only a logging part I've done, and the destructor I have already done the logging part, so as to know that when the object is being constructed and when the object is being destroyed, or when the means the object on a new is called on this object, and how many times you are calling the delete, or means how many times the object is getting destroyed. Okay, so let's see about this class bar, which has a member foo pointer, and that's take a pointer to an object foo. So in the constructor of this class bar, I'm just creating an object of foo here, and I'm taking this into a pointer. Okay, and as the rule says that if you are allocating some memory, then in the destructor you need to delete it as well. Okay, so I'm deleting that. I'm calling delete on that pointer to release the memory and to call the destructor on foo object. Okay, so delete will solve the purpose of releasing the memory that I've just allocated on the constructor of the bar. And now I have one function here. Now this is very important. Now this function get foo returns the pointer that is a member of a bar. Okay, so it is returning an object, and the object is of type foo pointer. Okay, so now any user or any developer can get an access to a pointer that's a member of some class, and this is what something which is not so good. Okay, so now let's see that here I just declared a foo pointer here, a pointer to a foo, and declared it, initialize it with null pointer. Now what I did, I create a bar, an object of bar on a scope. Say this is a scope, and on this scope I just created a bar object. So when I create a bar object, so basically on a stack I'm creating it on this scope, so it will be allocating the constructor will be called, and it will be allocating an object of foo here, and that will be assigned to foo pointer. That's a member pointer to a bar object. Okay, so and now on the same in the next line, what I'm doing is that I'm getting that foo pointer. I'm getting that object foo, a pointer to object foo, to a pointer here. Okay, to a pointer here. Now what will happen? Now, as we know that once we are having a valid pointer, then we are deleting it. Okay, so we can have here a check that if foo pointer is valid, okay, then just delete it. Okay, then just delete it. And in the foo pointer, when we are deleting it, we can also mark it as null pointer. Okay, so what we have done is that we have created an object of bar. So while we create it, we also assign this pointer a value. I mean, an object is being created, a foo object is being created. Okay, and when the scope will be over, the destructor of bar will be called, and this memory will be freed up, and the foo pointer will point it to null. Okay, so what we are doing before the destructor could be called on a bar object, we are taking the pointer, we are taking this pointer, foo pointer, which is declared in bar object, okay, outside. And when we are taking it outside, say we are just checking it and then we are deleting, we are calling delete on foo pointer. Okay, so it's a double delete. It's a problem called as a double delete. Okay, so that means we are having the bar object, when it goes out of the scope, it called delete on foo pointer, and now foo pointer is also, we are having the same reference to the same object, okay, outside the bar object. And when we call a delete over here, this is dangerous. This is called a double delete problem. Double delete problem. And that's what we want to avoid it. Okay, so now let me compile and run C, and let's see what could be the result. Yeah, so if I run it now, so see, in foo constructor, and then the destructor is called 2 times. Okay, so the destructor is called 2 times, so your program might crash as well here. Okay, because the foo pointer, suppose if the operating system has taken that memory and assigned to some critical area, and if you call a delete upon then it will be very fatal. Okay, your program might crash. Okay, so you see that the constructor is called 1 time, but destructor is called 2 times here. Okay, why? Because once the destructor of foo called when the bar object goes out of the scope, and the bar object destructor will delete the foo pointer. At that time the foo destructor was called, and now when we are having the foo pointer access to a foo with a foo pointer outside that bar object, and we call delete on that, okay, maybe mistakenly or something like that, we just call a delete on that, then again our destructor is being called. Okay, so the problem of how many references to a particular object is there, this was the problem, and this is being tackled here by shared pointer. Okay, so what the shared pointer internally does, it's just a wrapper, and that wrapper takes care of how many current references are there to an object, and once the reference count becomes 0, it deletes the object, it deletes the underlying object. So the destructor is being called only 1 time. Okay, so now let's see how the shared pointers solve this problem. Okay, so the shared pointer is declared in the header memory. Okay, and so let's do one thing. We declared it as a shared pointer, so shared pointer, and the argument is foo. Okay, so this now this becomes an object. Okay, and this object is a wrapper. Okay, so now when here, so how we allocate it is like this. We have a make shared, and we just pass the class we make an object of, like this. Okay, so what it will call a new, only a 1 time on foo, and the shared pointer object will be assigned to this. Okay, so at this time the reference count will be 1, because on 1, because only this the one you can say one, the reference is only 1 here. Okay, and so here also we in the destructor we do not need to call delete upon it, because once the bar will go out, once the object of bar will go out of the scope, it will call the destructor of this object as well. Okay, and this object, please understand that this object is having is a wrapper, and it is wrapping the underlying pointer, a pointer to an object of foo. Okay, and when this object will go out of the scope, it will check whether the reference count is 0 or not. Okay, so let's say now again we will not be taking a foo pointer, but here we will be taking and say shared pointer, foo here. Again, here we will be having the foo pointer. That's variable, and so here when we are getting get foo, so get foo again we are returning the foo pointer. So it is a, I have to change this also, because now it will be returning the shared pointer. Okay, so now let's see what is the use count. Pointer dot use count. So use count tells us how many currently references are there to this foo object. Okay, so current reference count is this much. Okay, so I hope to get the value as 2, because one reference count is we are having inside a bar object. Okay, and second is outside the bar object, so we will be getting 2 here. Okay, so and now after we come out of the scope, so the bar, after I come out of the scope, the bar object destructor will be called, and it will be destroying, see, the destructor will be called, and the destructor of shared pointer, this will be called, but it will be made sure that the underlying object is not deleted, because the current reference is still will be 1 this time. Okay, so now after out of scope, reference count is, again we check foo pointer use count, yeah. Good. So now I delete this also, because now there is no delete, because so now when this, so we say now this foo pointer, okay, so when it goes out of the scope, or when the main function returns, the foo pointer will also go out of the scope. So when this will go out of the scope, then the reference count will become 0, and hence the destructor on foo will be foo object. The destructor of foo object will be called, because when the reference count will become 0, the destructor will be called. Okay, so due to this referencing counting, it's make sure that the destruction happens only 1 when there are no more references left. Okay, so like we see the problem that previously the destructor was calling 2 times, a double delete problem, which was very hazardous, could lead to crashes. Okay, now let's run and see what happens. Now if I run the program, now see, so you have in foo constructor, yes, the foo will be constructed when I create the bar object. Inside the foo constructor will be created, and I get the shared pointer outside this, and so the current references become 2. Okay, one is inside the bar object and one is outside the bar object, so current references are 2. Now after the scope of this bar object gets over, then the destructor of bar object will be called, but the underlying object is not deleted. Okay, because the references is currently 2 minus 1, so the current references is still remaining. What reference is remaining is this foo pointer here outside the bar object. And now we see that once it goes out of the scope, the reference remaining is 1, and that reference remaining 1 is this foo pointer. And once it also goes out of the scope, then it destroys the underlying it calls delete on the underlying foo pointer. Okay, so then only one time the foo destructor is called now, only one time. So in this way the reference counting is being done in a shared pointer, and whenever the references becomes 0, then only the underlying object is deleted. So in this way it is being taken care that that there is no double delete here, and the underlying object is constructed once and deleted once. Okay, so in this way the memory management happens in case there are multiple references of if you see a code in which there are multiple references of an object. So in this way, using a shared pointer, it could be easily handled. So I hope you like this video, and thank you so much for watching the video. I hope you get a clarity on shared pointers. Thank you so much.